Today we're going to look at Chapter 8, Section 2, which is entitled Function Rules. This is on textbook page 587, and it goes through textbook page 590. Just another reminder that throughout the video, you need to write all of the notes in your textbook. You need to write the examples, doodles, etc. All right, so as you can see right here on textbook page 587, it should look like this. You've got a little girl eating some noodles. And let's go ahead and get started. On the next slide, you're going to see a more focused version so that we can work directly from the page. Okay, so here we go. Under the words vocabulary setup, vocabulary startup, this is where you're going to see some of those vocabulary terms that, remember, you do need to be studying so that you can do well on the vocabulary test at the end of the chapter. The first word, it says a sequence. It says a sequence is a list of numbers in a specific order. Okay, so specific order is important. Each number in the list is called a term of the sequence. So a term is just a number in the list. Pardon my dog and his squeaky toy. Arithmetic sequences, okay, so we've got two different types here. We've got an arithmetic sequence. It can be found by adding the same number to the previous term. So the key part here is the word adding. And then in the next one, it says in a geometric sequence, each term is found by, let's go ahead and underline geometric. Each term is found by multiplying the previous term by the same number. By the same number, that's important as well. All right, so let's think about now what we've just read so that we can compare the arithmetic sequence to the geometric sequence. So geometric, I underlined in blue, and arithmetic, I'm going to underline in purple. So purple and blue. All right, and I encourage you to also use different colored pencils while you're writing your notes as well. The only thing I would like for you to make sure you do is when you're doing the on your own portion, that you do those in regular pencil. All right, so here for the arithmetic sequence, you can see that I've went ahead and put the definition here for you. A sequence in which the difference between any two consecutive terms is the same. So, for example, between 3 and 6, you would add 3. Between 6 and 9, you would add 3. Between 9 and 12, you could add 3. So notice that the difference between each term is 3. And now you can see that the definition for geometric sequence is here, and it says a sequence in which each term is found by multiplying the previous term. So again, we have that word multiplying. And that goes with geometric here. Whoops. And in purple, we had the arithmetic. And that went with... Okay, so back to this geometric term here. Sorry. A sequence in which each term is found by multiplying the previous term by the same number. Same number. Multiplying, okay. So to get from 3 to 6, we need to multiply by 2. To get from 6 to 12, we multiply by 2. To get from 12 to 24, we multiply by 2. So hopefully that makes sense. Basically, the geometric sequence is used with multiplication, and the arithmetic sequence is used with addition. All right, and here under the words real world link, you see the problem. It says delivery. The China Palace sells lunch specials for $6 with a delivery charge, so it's $6, with a delivery charge of $5 per order. Fill in the table with the next 3 numbers in the sequence. So we need to determine if this is going to be an arithmetic sequence or a geometric sequence. So we can see that we're increasing the specials by 1, 2, 3, 4, 5, 6, 7. So now we need to find out what the relationship is here. So to get from 11 to 17, I can't immediately think of a way that I can multiply 11 and get to 17. So let's think about addition. To get from 11 to 17, I could add 6. So now let's see. 17 plus 6 gives me 23. So plus 6. Plus 6. So to find the number that goes here in this next spot under 5, you would take 29, which is the number in the sequence, and then you're going to add 6 to it, which gives you 35. So under that one, under the 5, you put 35. All right, so then to get the number for the next one, let's go ahead and go to green here. We take our previous number, which was 35. So we got that from right there. And we're going to add 6. You guessed it. So you get 141. And the last one. And the last one, you're going to take the previous number, which here was 41. We got it from here. We're going to add 6, and we get 47. All right, so as you can see, this is how we fill in the table. Now we're looking at textbook page 588. So you can see me circle that at the bottom there. I'm also going to write it right here, textbook page 588. And on the next slide, you're going to see us zoom in so that we can work through those problems. All right, arithmetic and geometric sequences. Determining if a sequence is arithmetic or geometric can help you find the pattern. So the reason you would want to know is because you would want to find the pattern. When you know the pattern, this is important. When you know the pattern, you can continue the sequence to find missing terms. So let's look at example 1. In example 1, it says, describe the relationship between the terms in the arithmetic sequence. So immediately, I'd like you to go ahead and underline arithmetic sequence. And off to the side, I want you to write what that means. That means that you're going to be adding. So this is a pattern that you will find by adding. Okay. So then you can also see it says, then write the next 3 terms. So to get from 7 to 14, you need to add 7. You can see they've done that here. Let me change colors so that you can see. You can see they've done that here. Add 7, you get to 21. Add 7, you get to 28. And remember, they're asking you to add the next 3 terms. So we would take 28. And remember, we're adding 7 each time. So we take 28 plus 7. Okay, and as you can see here, we have taken 28, which was the previous number right here. We got 28 from the last number in the pattern. We added 7 because, as you noticed, we were adding 7 here, so we added 7 here. And we got our new number in the sequence, which would be 35, which is what they got. So remember, when I write off to the side, I would like you also to write off to the side. Then for the next one that I used purple, we went from 35 plus 7, and again, we got the 35 from this one. So 35 plus 7 gave us 42. And then 42, last but not least, plus 7 gave us 49. Now just note again that we were adding 7 each time. Okay, now it says, for example 2, describe the relationship between the terms in the geometric sequence. So right away I want you to, as soon as you see geometric sequence, off to the side, you're going to write multiply or some abbreviation for it. And that's just so that you remember that geometric goes with multiplying and that arithmetic goes with adding. It says then write the next 3 terms. So you would look and see between 2 and 4, how do I get from 2 to 4? Well, you could add 2, but you could also multiply 2. So how can you determine? If this hadn't said geometric, you could determine this by then going to the next term. Well, if I add 2 to 4, I get 6. And the next one in their pattern is 8. So you know this can't be an arithmetic sequence. It has to be geometric. So you're going to, as they stated here, multiply by 2, multiply by 2, multiply by 2. So then you want to take the next one in the pattern, in the sequence. So you had 16. Oops. So you have 16, and you multiply that by 2, and you get 32. So 32 comes next in your pattern. Then you're going to take that 32, and you're going to multiply by 2, and you get 64. So you're going to throw 64 up here. And last but certainly not least, let's go ahead and make that a little smaller too. There we go. Now you're going to take that 64, and you're going to multiply by 2, and you get 128, which would go right here. So we got 128 like they got. We got 64 like they got. And in green we have 32 like they have. All right, so now let's go ahead and look at got it. Do these problems to find out. So what I would like you to do is, in just a moment after I give you the instructions, I would like you to go ahead and pause the video so that you can start the problems. I would like you to write A, and then I want you to write 0. Whoops. Make that a little smaller. Okay, I would like you to write 0, 15, 30, 45. Okay? And then after that, whatever you're going to write, it says you are going to need to. What they're really looking for in the answer is the first thing they want is the next 3 terms. But they also want you to describe the pattern. So we need to look. Well, I could add 15, that's really all I can do. Because you have 0 here, remember, this absolutely positively cannot be a geometric sequence because 0 times anything is 0. So because this one has 0, it's automatically an arithmetic sequence. So you have to add 15, add 15, add 15. So then again, in order to get to the next one in the sequence, 45 plus 15 is 60. And then 60 plus 15 is 75. And then 75 plus 15 is 90. So you should have 60, 75, and 90 for your answers. And you would want to say you are going to add 15. That's fine. And actually, I should probably have you write a more extended version here. So instead of just add 15 for A, let's go ahead and say that each term is found by adding 15 to the previous term. So each term is found by adding 15 to the previous term. Whoa. All right, so the reason I want you to go ahead and write it all out here, and you can write it where you can find space. If you need to write above in the margin so that you can get it all in there, that's totally fine as well. I just want you to be able to write the entire sentence because I need you to be able to explain how to find each term. Now, you want to also keep in mind that just because I need to clarify that with the arithmetic sequences, it's not just adding, it's adding or subtracting. So the geometric sequences could also be multiplying and dividing. All right, welcome back. For B, notice we have written all of the information there, and we've discovered that the pattern to get from 4.5 to 4, we had to subtract 0.5. To get from 4 to 3.5, we subtract 0.5. 3.5 to 3, we subtract 0.5. And now we're going to go here to get from 3 to our next term, in the sequence. Hold on one second, my dog's crazy. Okay, so to get to the next term, we're going to take 3, and we're going to subtract 0.5, which gives us 2.5. So we know that 2.5 is the next number in that sequence. Let me actually do that in green so that it matches. Okay, and here you can see that we've taken 2.5, which is that green one right there, and we've moved it up to our next space so that we can then find the next term. 2.5 minus 0.5 leaves us with 2.0, which remember 2.0 is actually just 2. All right, and then you can see my explanation down here. I've shortened it a little bit, so all you need to write is subtract 0.5 from previous term. So that just means to find the next term, you subtract 0.5 from the previous term. All right, now we're looking at C. We have 1, 3, 9, and 27. Hopefully right away you notice that this is a geometric sequence, but if you didn't, the way that you determine that is you have to ask yourself, okay, to get from 1 to 3, I could add 2, or I could multiply by 3. Well, let's see what we have between 3 and 9. So if I add 2 to 3, I get 5. And since 9 is the next to my sequence, I know that this is not an arithmetic sequence. This has to be a geometric sequence. So now I've decided it's going to be times 3, times 3, times 3. So now to find the next number in my sequence, I am going to take 27, which we got from right here, and I'm going to multiply that by 3. Let me go ahead and move this up just a smidge so we've got room for our explanation. So after we do the multiplication there, we find out that the next number in our sequence is 81. All right, and as you can see, I've done C here. We finished up. We did 81 times 3, which gave us 243. And then you can see that arrow comes all the way back up to the 243, and we multiply that by 3 to get 729. The rule I've written in purple is to multiply the previous term by 3. All right, now we're going to go ahead and take a look at D. In D, because remember, sometimes it won't be obvious right away, so you have to make a decision about how you can get from 3 to 6. I can get from 3 to 6 by multiplying by 2, but I can also get there by adding by 3. So now we need to go on to our second number in the sequence just to test it. So if I was adding 3, 6 plus 3 would be 9, and 12 is the next in my sequence. So I know that this is not an arithmetic sequence. This has to be a geometric sequence. So what that means is that I'm going to be multiplying by 2. 3 times 2 is 6. That's how we got from here to here. 6 times 2 is 12, so times 2. 12 times 2 is 24, times 2. And now we're going to do the next one in the pattern. Okay, and as you can see here, I went ahead and finished the sequence. We have 48, 96, and 192 in the sequence. And in purple, you will see the rule or the pattern, which is multiply the previous term by 2. All right, as you can see now, we are on textbook page 589. So textbook 589, and on the next slide, we're going to go ahead and zoom in so that we can get started on that one. All right, on textbook page 589, it says find a rule. So let's go ahead and outline find a rule here. Find a rule. All right, so it says a sequence can also be shown in a table. The table gives both the position of each term in the list and the value of the term. So in order for you to be able to set the table up, you need to have both the position of each term, so that's important, and you also need to have the value of each term. So the placement is important, and then the numbers that you put in it are important. All right, so right here it says that, again, the table gives both the position of each term and the list of the value of the term. So we've got the list as 8, 16, 24, and 32. Now, you can write an algebraic expression to describe the sequence. So writing an algebraic expression, it says the value of each term can be described as a function of its position in the sequence. So I know that kind of is very wordy, so I'm going to try and break the next piece down. It says in the table above, the position, so that's this right here, can be considered the input. So remember, we used x for the input, and the value of the term can be considered the output. So that's going to be the output, and we can call that y. So if we were to make a function for this specific problem, we could look at it and go, okay, first the rule is going to be, if you look from 1 to 8, so from 2 to 16, so the rule is going to be 2. The rule or function for this particular problem would be 8x, because whatever position you're in, like for instance the second position, if I put 2 in now for x, 8 times 2, because I substituted 2 for x, then I get 16. And if you notice, 16, which is my output, matches my output here. In example 3, it says to use words and symbols to describe the value of each term as a function of its position. So remember again, though, that the position is going to be like x, and actually they did it with this one as n. I'm sorry. Let me go backwards here. All right, so this is going to be n. And they want you to describe it. It says, then find the value of the 10th term. So first, you need to use symbols and words to describe the value of each term as a function of its position. So remember, position is n, function of the position. So if it's a function of n, we're going to look here. Now, first, let's go back to what we just learned about finding the pattern. It says, notice the value of each term is 3 times its position. So meaning 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, and so on. So the value of the term in position n is 3n. So that's really important what they just told you, because basically that's the function, 3n. So you can put any number in for n to find out what the value of the term is in that position. So now it's saying, now find the value of the 10th term. So that means we're going to take the equation 3n, and we're going to plug it in. So we've got 3 times 10, and then that gives us the value of 30. So that's how we know that 30 is going to be in that 10th position, which is what they got right here. You can see on the table, I went ahead and put a 10 over the n, and I put 30 just below the 3n. All right, so now it says to use words and symbols to describe the value of each term. So basically, you have to be able to come up with the function, which is the rule. So that's the first step, to describe the value of each term as a function of its position. So this is going to be a 2-part problem. Then the second part is, it says find the value of the 8th term. See that? 8th term. Okay, you need to know that. So now thinking aloud, we need to look at these numbers. So what's the relationship between 2 and 12? Well, I can multiply by 6. So 3 and 18, I multiply by 6. 4 and 24, I multiply by 6. Okay, great. So what that means is, this is me describing, hold on, let me go backwards. So times by 6, times by 6, times by 6, and so on. So what that means is when I'm answering this question that I've circled in red, basically describing the value of the term, of each term as its function of its position. What I'm trying to say is I've just found out that multiplying by 6 is how you get it. So it's going to be 6n. My function there is going to be 6n. So I can plug any number in now for n. But what's the number they want you to plug in for n? So this is the first part of my answer. You need to write that. And you also need to make sure that you've written the times 6 times 6 times 6. So now they're asking you, it says then find the value of the 8th term. So that means we're going to take that function. So we'll write 6n again. Please do write that again. And then we're going to go, okay, 6 times 8, because we're saying that n is equal to 8. So then 6 times 8 is going to give you 48. So my two answers are 6n and 48. They also want you to add the words. So they want you to have 6, whoops. All right, so I stand corrected. We needed actually 3 boxes because we have 3 different answers. We've got 6n, which we need. We have the value in position 8. And then we have the description in words. So 6n was the description with symbols. 6 times its position number is in words, and 48 is the value. All right, so now we're looking at table F. So we've got the position, which is 3, and then right away we think, okay, can we get from 3 to 7 with multiplication? We really can't. So then we should probably start leaning towards the arithmetic sequence. And with the arithmetic sequence, to get from 3 to 7, you would have to add 4. So let's check it on the next one. 4 plus 4 is in fact 8, so that's good. 5 plus 4 is 9. 6 plus 4 is 10. Excellent. So I think that we found our arithmetic sequence. Our arithmetic sequence is going to be found by taking n, the position, and adding 4. The next piece says, remember, find the value of the 8th term. So that means we're going to take n plus 4, and then we're going to substitute 8 plus 4 because we're saying that n is equal to 8 because it's asking us for the 8th term like it did right here. So now 8 plus 4, 9, 10, 11, 12. So we get 12 for our value. That's the second piece of our answer. And remember, you need one more piece. And that one more piece is to describe it in words. So, all right, and for our last piece, we need to write it in words, which is add 4 to the position number. So that's the same as us saying n plus 4, but this is actually describing it in words. So notice I've circled words in orange, symbols in red, and the value in purple. All right, so right here you see we're on textbook page 590. So this is just a far out view so that you can see what page number we're on. And in the next slide, it's going to be zoomed in. Okay, example 4 is actually going to go over one of the tougher problems. And that's pretty much true to form for the book. They usually save the tougher ones for the last example. So you want to make sure that you follow along in this one and maybe even listen to it a couple times. The table shows the number of necklaces Ari can make based on the number of hours she works. Write a function rule to find the number of necklaces she can make in X hours. So it says to find the rule, determine the function. Okay, notice the values 5, 7, and 9. So you see there's 5, 7, and 9. And then I'm going to go ahead and erase that because I just wanted you to see where that was. So notice the values 5, 7, and 9 increase by 2. So 5, to get from 5 to 7, you add 2. To get from 7 to 9, you add 2. So because they increase by 2, you know that the rule includes 2x. See how they've said that there? So you know that it's at least 2 times the amount, okay? But if the rule was just 2x, then that means the first one would be 2 times 1, and so you should have 2. But because the value is actually 5, 5 is 3 more than 2. So then it would actually be 2x plus 3, because we need 3 more than 2 to be at the 5 that's right here. So then we've come up with this sort of testing thing we have here. So it says, but this value is 5, which is 3 more than 2x, which is what I said right here. So let me just kind of point out. That's what we just did right there. So now it says to test the rule, 2x plus 3. So I'm going to do 2x plus 3. That's my little testing thing here. And it says to test the rule, use the guess, check, and revise strategies. So we've got 2x plus 3. Let's look and see if it works for 2 when we put 2 in for the value. Okay, and as you can see, I did the problem below here. We've got 2 times 2 plus 3. 4 plus 3 is 7. And since 7 is the number in our output category here, that one works. Let's check the next one. Okay, as you can see, I plugged in the 3. Notice I circled that 3 in purple. So I plugged in 3 to our rule, and we've got 2 times 3, which is 6, plus 3, which is 9, and as you can also see, 9 is the output for 3. So it looks like we have a good rule. So the rule for number 4 is the rule 2x plus 3 represents the function table. All right, so on this page, normally I don't have you do that last question, but in this particular section, I would like for you to do all 4 problems, and don't forget to rate yourself at the end. I look forward to our next class session together.